In this video, we are going to create a hydraulic cylinder assembly using Siemens NX. So these are the individual components of the hydraulic cylinder. We have the barrel, the flange, the gasket, the piston, and the screw. And then you have the exploded view here. We are also going to see how we can do that. All the dimensions are in millimeters. We have the parts list table, which contains the parts name, the ID or the number of the parts from 1 to 5, which means we have 5 parts here in total, and then the quantity of the parts. So for every part, we need just 1, except the screw, which we need 4. And these are the drawings for the parts as well. So this is a very simple tutorial. Make sure you watch the video to the end. In this first video, we are going to model the individual parts from the barrel to the shaft. And then in the next video that comes right after this, we're going to create the final assembly. And then we add the exploded view. Please like the video, subscribe, and turn on post notification so you get a notification anytime I upload a video. And make sure you share this video to your friends as well so they can also watch it. Now, write in the comments below, done, if you are able to complete this assembly with me. And also let me know in the comments the next assembly you want us to do together. Now let's start. First, I will create a folder to hold all the files. So in the desktop, we create a folder and call it Hydraulic Cylinder Assembly. So this is the folder here. And then we open Siemens NX. So we are inside the Siemens NX window. You have to create a new file, the workbench model, and the units as we saw millimeters. Create the first part, which is the barrel. And then you save it in the folder hydraulic cylinder assembly that you created. Okay. So click OK and it will take you to the Siemens NX 3D modeling workbench. Now on the barrel, you can see we have the middle shaft, this circular flange, a rectangular flange, or a square flange as you can see. And then we have another shaft coming outside here and a flange as well. Then we have some holes we are going to create as well and some fillets. So let's first create the middle cylinder here. So extrude, because we are adding material. Sketch section. We're going to sketch on this XZ plane, which is the front plane. Okay. And we have an outer circle of diameter 50. And then an inner circle, which will be this hole of diameter 40 millimeters. So finish. And then the length of the cylinder is 100 millimeters, as you can see. So we need a symmetric value so that we can have half of the 100 on one side and half on the other side. So a symmetric value of 100 divided by 2. Apply. Then you have the square flange here. Since the full length is 120 and this inner length is 100, that means 120 minus 100 is 20 millimeters. So 20 millimeters will be the length of these two flanges. And looking at the top view, this flange, which is the circular flange, has a length of 10 millimeters. So that means this rectangular flange here also has a thickness of 10 millimeters. So we create the rectangular flange. So sketch section, rotate, and then click on this face. We want the y-axis to come to the top here, so come to CSYS dialog, and then we want to reverse the x-axis direction. So the y-axis is at the top, the x-axis is here. Okay. So we need a rectangle with the from center method and then less dimension. So this is a square of length 60 millimeters. So first make sure this line and this line are equal. So give them the equal length constraint, and the length is 60 millimeters. Then we need the hole here as well. So instead of drawing the hole or drawing a circle, just use a project curve to project this hole onto the sketch. Finish. And yes, the flange should move in this direction and a distance of 10 millimeters. Set the boolean to unite with this shaft. Okay. The flange has fillet of radius 7.5 at the corners, so edge blend, a radius of 7.5. Click on the 4 corners here. Okay. And then we have 4 holes here as well of diameter 9 millimeters, and then they are separated from their centers by a distance of 45. A square here as well, so 45 and 45. So create a hole, a simple hole of diameter 9 millimeters. Set the depth limit to until next. You're going to sketch the centers of the holes. So rotate and then click on this face. Okay. So we need a square again from center and the center here. Click on the 2 lines here, the vertical and the horizontal line, equal length. And then click on them and make them construction lines. So click on all the 4 lines, convert to reference. And then with the point to replace the centers of the holes on the 4 corners. So this length here is 45. So we can see sketch is fully constrained. Finish. Okay. And then we add this shaft here that goes to the top like this. So we are going to add a datum plane at a distance from this center here. So the distance is 50 millimeters. And then click on this XY plane. Okay. Extrude. And then we click on this sketch here. Need a circle, and the diameter of the circle, as you can see, is 32 millimeters. We want to place a circle in the middle, so click on the center and then this y-axis, point on curve. The distance from the center of the circle to this end here is 35. So from this center to the end here is 35. Sketch is fully constrained, so finish. Then you're going to reverse the direction for the shaft to come inside, and then you set the end limit to until next, so it can touch this shaft. Boolean unite, apply. And then we add the circular flange as well. So again, extrude. Now click on this face. Okay. The diameter of the circle is 54 millimeters, looking at the top view. Finish. Again, we reverse the direction for it to come inside, because the 50 millimeters where the datum plane is covers the full length of the flange as well. So let it come inside, and the thickness of the flange is 8 millimeters. Again, Boolean unite. Okay. And then you create holes as well here. So first have a counterbore hole through the center here. A counterbore hole of counterbore diameter 30. Zoom in. The counterbore diameter is 30. The hole diameter is 20. And the counterbore distance or the counterbore depth is 4. The hole is up to the next. Sketch section. Sketch on this face. And with the sketch point tool, place a point on the center of the counterbore hole on this center here. As we can see, finish. Apply. Then you have 4 simple holes here of diameters 6 millimeters through to the next surface. The circles are separated at a distance of 42 millimeters. So we sketch a circle of 42 millimeters. That will be the guide for the centers. So simple hole of diameter 6 until next, and then we sketch on this face. We will have a circle of diameter 42. Convert the circle to a reference circle. And then we'll have the first point somewhere here. Now we want to make sure the point is in line with the vertical axis. So right click, select from list and click on the point. And then click on the y-axis, point on curve. You can see sketch is fully constrained. We want to have 4 of them. So pattern curve. Click on this point for the curve to pattern. The layout should be circular. The rotation point, click on this center here. And then the spacing, count and span. We need 4 points in total. So 3 additional points. And then the span angle 360 degrees for a full circle. Okay. Sketch is still fully defined or fully constrained. Finish. Okay. We are done with this. We add this flange as well. So the flange has a diameter of 80 millimeters. So again, extrude, sketch section on this face, a circle of diameter 80 millimeters. Then we need the hole as well. So again, we project this hole onto the curve or onto the sketch, and then we finish. Now the flange should come in this direction here, not in the opposite direction. It should be excluded from the length of this shaft. So make it come in this direction. And the thickness of the flange is 10 millimeters. Boolean unite. Okay. Then we'll create the holes here. But these holes have threads as well. So you're going to create one hole and add the thread, and then you pattern them in a circular manner. So hole, a simple hole of diameter 8 millimeters. Again, depth limit until next, and then we sketch on this face. The holes are separated at a distance of 60 millimeters. So a circle of diameter 60. Convert the circle to reference. We are going to use the same method we use for these circles as well. So with the sketch point to place the point here. And then right click, select from list and click on this point. And then the vertical axis, point on curve. Sketch is fully constrained, so finish. Okay. Then we add the thread of size 10 millimeters by 2 millimeters. So the 10 is the diameter of the thread and the 2 is the pitch of the thread. So under more, we have the thread feature here. You have a detailed thread, and then click on this area of the hole. You can select start and make the thread start from this face and in this direction. Okay. So the major diameter 10 millimeters, and then the length of the thread, since the thickness of the flange is 10 millimeters, you can just add an offset of 2 millimeters so that the thread will be perfect at this face, and then a pitch of 2 millimeters. Angle is okay, and click on OK, and you can see this is the thread here, as we can see. Now we want to pattern the hole and the thread in this manner. So come to pattern feature, move the feature tree here, and then first click on this simple hole, hold the shift key and click on this thread as well to select the two features. Otherwise, if you don't do it like that, it will not work. Bring the feature tree back, and then the layout circular, axis of rotation, we can just click on this circular face. The spacing, count and span, we need 4 holes and threads, and the span angle 360 for a full circle. Okay. This is what we have. Next, we add the fillets here of radius 2, and then you change the color to salmon. So edge blend, a radius of 2, click on this edge, and then this edge as well. Due to the nature of this hole and thread, we cannot add the fillet here, so okay. Then you want to hide everything unless the body, so come to view, show and hide all, and then show only the solid body. Then you change the color to salmon. So this is the salmon color. Okay. Then we save the parts, and then we move on to the next part. So create a new file. The next part is the flange here, as we can see. The flange is a circular feature, so we are going to use the revolve. So down here we have the revolve feature. I'm going to sketch on this right plane, which is the YZ plane. You're going to sketch half of the profile here, and then dimension. The outer diameter is 80 millimeters, and the inner diameter here is 38 millimeters. Since we sketched half, we have 38 divided by 2, and then 80 divided by 2. The full length is 30, and this length is 20 millimeters. Sketch is fully constrained, so finish. And then the axis of revolution, since the sketch falls on the y-axis, just click on the y-axis to be the center and the axis of revolution. Okay. You have a countable hole through here. The hole feature, a counterboard hole of counterboard diameter 25, counterboard depth 16, and a hole diameter of 14 through. Depth limit through body, and then we sketch on this face. Now with the sketch point to replace the center here on the center of this circle. Finish. Okay. And then we add a thread here the thread A, which is the bigger thread, has a size of 16 millimeters by 2 millimeters. So thread feature, a detailed thread, and then the thread will be on this face. The start point of the thread on this face, but the thread is coming in this direction, so reverse for it to come inside like this. The major diameter is 16 and the pitch is 2. On the length of the thread, let's calculate it. So the full length here is 30 and the counterbore depth here is 16. So that means 30 minus 16 will be the length from this face to the end here. That will be 30 minus 16, and then we add an offset of 2. So the length of the thread into brackets 30 minus 16. That will be the actual length, and then we add an offset of 2 for a perfect thread at this face. Okay. Then we add a chamfer of 3 millimeters symmetric here. A symmetric cross section of distance 3, and then click on this edge. Okay. Next, we have 4 counterbore holes here as well with threads of size 10 by 2 millimeters. Now, just like we did for the barrel, we are going to create one hole and add the thread, and then we pattern the hole in the thread together. So let's create the first counterbore hole. Hole feature, counterbore hole of counterbore diameter 15 and the hole diameter 8. And the counterbore depth is 6 millimeters and the hole is through the body. We sketch on this face, but we want the y-axis to come on top. So again, CS wires dialog, and then reverse the direction of the x-axis for the y-axis to come on top. Okay. Now the holes are separated from the centers at a distance of 60 millimeters. So a circle of diameter 60 from this center here. Convex this circle to reference. And then replace the first point here. Now, right click, select from list and click on the point. And then this z-axis, not this. This x-axis is in the actual center. So click on the z-axis here. Point on curve. As you can see, sketch is fully constrained. Finish. Okay. So this is what we have. And then we place the thread here. A detailed thread on this face. Now the start point of the thread should be on this face. And then reverse the thread axis for it to come here. Major diameter 10 and the pitch 2. Now the length of the thread, since the full length here is 30 minus 2, which will be 10. The full length here is 10 and the counterbore depth here is 6. So the length of the thread will be 10 minus 6. Then we add an offset of 2. So the length into brackets 10 minus 6 and an offset of 2 millimeters. Okay. Then the same way we pattern. So pattern feature. And then the features to pattern. Click on this counterbore hole. Hold the shift key and click on the thread to select both the counterbore hole and the thread. Now on the axis of revolution, click on this circular face. Make sure the layout is circular as well. Count and span 4 holes and threads, and then the span angle 360 degrees. Okay. So this is what we have. Then we change the color to peach. So again, we hide all and then show only the solid bodies. And then you change the color to a peach color. So this is the peach color. Okay. And then you save the part. Move on to the next part. The gasket. So for the gasket, you can see it's also a circular feature. So we sketch this circular cross section and then revolve around the horizontal axis. So revolve and then you sketch on this right plane. First off, we have the circle of diameter 2.5. Then you place the circle in the middle here. So click on the center and the vertical axis here, point on curve. You have to calculate the distance between the center here and then the center of the circle. So the distance between the center and this circle will be the radius of this circle, which will be 34 divided by 2. The distance from this center to this point. And then the distance from this point to the center of the circle will be 2.5 divided by 2. So the distance between the center and this horizontal axis will be, into brackets, 34 divided by 2 plus, into bracket, 2.5 divided by 2. The system will calculate for us 18.3. Sketch is fully constrained. Finish. We are going to revolve using the y-axis. Okay. So this is the gasket. Change the color to iron gray. So show and hide all, and then show the solid body. Change the color to iron gray. Okay. And then we save the part. Then we move on to the next part, which will be the piston. So again, we create a new file. Okay. This piston here, as you can see, is also a circular feature. So again, we use a revolve on this right plane. So we sketch half of the profile and then we can dimension. I'll make this line horizontal. This diameter is 12. This is 16. So since we sketched half, this will be 12 divided by 2. And this will be 16 divided by 2. And this is 38 as well. So 38 divided by 2. The full length is 100. And then the distance from this point to the end is 20. Then from this point to this face is 70. This angle here is 45 degrees with the horizontal. So we use the angular dimension of this inclined line and this horizontal line. The angle here is 45 degrees. You can see the sketch is fully constrained. You're going to add this cut to it. So we have a detailed view here, as you can see. So zoom in. Then you have an inclined line, a horizontal line, and another inclined line as well. Now we have vertical lines here, and the angle the inclined lines make with the vertical is 5 degrees. So vertical lines here. Click on the line and make it vertical. If it is not, this is vertical. You make the two lines reference lines. Now the angle between the vertical lines and the inclined lines 5 degrees. And then the distance from this end to the point here is 3.5. From one point to this point here is 3. So this time, rapid dimension from this point to this point here is 3.5. And then from this point to this point is 3. And then from this line here, the diameter is 34. So since you sketched half, from this line to this horizontal axis is 34 divided by 2. Okay, the sketch is still fully constrained. So you're going to trim this line from it. Trim this as well, and trim this. Sketch is still fully constrained, so this time finish. And then the axis of revolution, use the y-axis. Okay. Looking at this detailed view, we have fillet of radius 0.2 on this corner and then a radius of 0.4 on these two corners. So edge blend of 0.2 first on this corner and this corner, apply, and then 0.4 on this corner and this corner. Okay. Then we have the thread of size 14 by 2 millimeters. So thread, a detailed thread on this shaft. You have to select the start point. So click on this face here, reverse for it to come inside. The minor diameter is 14. The pitch is 2. Then the length of the thread. Since we started the thread on this face, you have to get the length from this face to the end of the thread here. The thread length is actually 65. So from this start of the thread to this face here is 65. So we add the 20 to the 65. So that will be 20 plus 65. Okay. So this is the thread as we can see. Then we have chamfers of distance 1 millimeter symmetric. On this edge, and then this edge here. So click on this edge, and this edge. Distance of 1 millimeter. Okay. You can change the color to silver gray. So show and hide all, and show the solid body. Change the color to silver gray. Okay. Save the parts. And then we move on to the next part. So the last part is a screw. Okay. The screw is also a circular feature. So revolve. We sketch again on the right plane. Sketch half and then dimension as we always do. Make this line horizontal. the inner diameter 10, and this outer diameter is 15. So this will be 10 divided by 2. This will be 15 divided by 2. This length is 14, this is 6. Sketch is fully constrained. Finish. And the axis, the y-axis, okay. We have a cut here, so extrude. Sketch on this face, okay. So a rectangle by 2 points. The first point here, second point here. Place the rectangle in the center. So locate the midpoint of this vertical line, and then this x-axis point on curve. Now for the length of the rectangle, you don't need a fixed length. So far as it covers the full length here, it's okay. And then the height or the width is 2 millimeters. Click on this corner and pull the rectangle here. Again, pull this one here to cover the full diameter here. Okay. Reverse for it to come inside. The length of the cut is 4 millimeters. Boolean subtract to remove material. Okay. Then we'll have a thread of size 8 by 2 millimeters. A detail thread, click on this shaft. The start point will be this face, and this is the right direction, so okay. Minor diameter 8, and the length is 14 plus an offset of 2 for a perfect thread at the end here. Pitch is 2 millimeters, okay. Change the color to granite gray. So view, show and hide all but the solid body. Then you change the color. I have the granite gray color here. Okay. Then you save the parts. And here, this is the end of the video. We have modeled all the parts that we need. In the next video that comes after this, we are going to finally create the assembly and add an explosion view as well. So I'll see you in the next one.